Let's talk about some of the attributes or characteristics of quadratic functions. Let's begin with domain and range. First of all, let's figure out what domain is. Domain is the set of all x values for which a function is defined. So it's all of the x values that appear on the graph. And to find it from a graph, what we're going to do is we're going to scan the graph with our eyes, not with like a scanner or anything. We're going to scan the graph from left to right, and we're going to give that answer in interval notation. And one important thing to note is that for all parabolas, have the same domain. The domain is negative infinity to infinity. Range is going to be the next attribute or characteristic. Range is the set of all y values that result from a function. So it's going to be all the y values that appear on a graph. And the way that we find range given a graph is that we scan the graph from bottom to top. And we're going to give that answer also in interval notation. Now the range is going to be different for each parabola, and the way that we find that is basically if the parabola opens up, the range is going to start at its vertex. So when our parabola opens up, let's say, let's make up just letters. How about MR? So if it's 5, 7, or whatever, we're interested in, these will be numbers for our parabola. So if your parabola opens up, then when you scan the parabola from bottom to top, down at negative infinity, there's not any parabola. The parabola doesn't kick in until right here, and that is at the y value r. And then the parabola keeps going, keeps going, keeps going forever. So the range will be from r to infinity. Now in interval notation, the infinities always have open parentheses, and if you have a closed dot on your value, then it will have a closed bracket like that. So the range will be from r to infinity, and remember that that r is the y value of the vertex. Then if your parabola opens down, let's give it the same letters, M, R. So when the parabola opens down, the range will go from, if we scan bottom to top, down at negative infinity, I have lots of parabola because that keeps going. Negative infinity all the way up to this value right here, and that is the last y value that's on the graph. So the range will go from negative infinity up to r, and then it quits. So the range will be negative infinity up to r, and then a closed bracket. And remember that r is the y value of the vertex. The next feature we're going to talk about is the extreme value. Extreme values. Extreme values mean the maximum or minimum values. So the maximum or minimum. Now the maximum is the highest value, and we're really talking about y value, and the minimum is the lowest y value. And both of these extreme values occur at the vertex. So the extreme values occur at the vertex, and the vertex, what we're interested in is that the value of the extreme, whether it's a maximum or a minimum, is the y value of the vertex. So let's look at a parabola that opens up and a parabola that opens down. If your parabola opens up, then what happens is the parabola has a rock bottom. The rock bottom happens right here at the vertex MR. That's what we called it before. So when the parabola opens up, it has a minimum at its vertex, and the value of the minimum is the y value of the vertex that we've been calling R. When a parabola opens down, I'll label that again. When the parabola opens down, as you go left to right, the parabola is creeping up, and then it gets to its highest point, and then it comes back down. This is a maximum value. So this parabola has a maximum, and the value of the max is the y value of the vertex, R, as we've been calling it. The next characteristic we're going to talk about for these parabolas is where they are increasing and decreasing. Now, when you are looking at where a parabola or any graph is increasing or decreasing, you always want to read the graph from left to right. So we're reading the graph from left to right. Increasing means the graph is going uphill. So if it was like a roller coaster, as you ride the graph from left to right, are you going uphill or downhill? And then decreasing means going downhill. And what we're going to do is we're going to list the intervals where it's increasing and decreasing using their x values in interval notation. This is going to take some practice. Let's look at our uphill or our opening up parabola and opening down parabola again. So in our opening up parabola that had that vertex at MR, and our opening down parabola MR. So this one opens down, this one opens up. As we go from left to right, starting at negative infinity, if you were riding along this parabola, you would be going downhill. So you're going to go downhill, downhill, downhill as we go left to right, downhill, 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 until right here. And at this spot right here, you have hit rock bottom. So this parabola is decreasing on the x values from negative infinity all the way out at the left up until the x value right here, which is m. And then at that value, it turns around and you start going uphill. So then you are increasing from the x value there of m to positive infinity. Now on the opening down parabola, as I go left to right, if I start out here at negative infinity and I'm walking along that graph, I'm having to go uphill, 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 uphill until I get right here. And then I hit the top of the mountain and turn around and start going downhill, 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 downhill. So this parabola is increasing from negative infinity to this spot right here, which is the x value of m. And then it starts decreasing, and it decreases from m to positive infinity. We always use open circles on infinities, and we also use open circles when we talk about increasing and decreasing, because right here at that turnaround spot, it's not increasing or decreasing, it's just turning around. The very last feature we're going to talk about before we go back and look at the graph is where a function is positive and negative. A graph is positive where the graph is above the x-axis, and the graph is negative where it is below the x-axis. And these are also going to be listed using interval notation of x values. So list using x values in interval notation. And again, we're going to go left to right. Okay. So let's look at an example of a parabola. And let's say this parabola goes like that. Okay. So here's my x-axis and my y-axis. And what I'm interested in as far as where the graph is positive is when it is above the x-axis. So if you use something to cover up everything below the x-axis, you can see that this graph is above the x-axis in all of that zone. So it is positive everywhere that it's above the x-axis. So all of these x values, as I go left to right, it is above the x-axis. Then where it's negative is below the x-axis. So I'll cover that up this direction. And all of these values are below the x-axis. So negative, 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 negative. And then it starts again, negative, 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 negative. So what's happening where it switches from positive to negative? Well, it switches where the equation is not positive or negative. It switches right here where the equation equals 0. So these are my x-intercept. So when we list our values or our intervals for positive and negative, what we need to remember is that it switches from positive to negative at x-intercepts. So generally speaking, what you're going to have is you're going to start your positive or negative out at negative infinity, and then you're going to go up to some x-intercept, and then generally it will switch and go from x-intercept, one x-intercept to the other x-intercept, and then it will be again from the x-intercept to infinity. So from x-intercept 1 to x-intercept 2, and then from x-intercept 2 to infinity. In this example, it would go negative from here to this x-intercept, and then again from here to here, and it would be positive between the two x-intercepts.